I wake up again, but it feel like I'm dead. I don't understand how you can feel this way. I don't wanna move, so now I'm in my head, and I'm not sure if I'll see another day. Won't be long before I'm leaving it. I don't want you near.
OpenGL. What is OpenGL? OpenGL or Open Graphics Library is a cross-language, cross-platform application programming interface API for rendering 2D and 3D vector graphics. The API is typically used to interact with graphics processing unit or GPU to achieve hardware accelerated rendering. NGL is used in a wide variety of applications including video games, computer-aided design, scientific visualization, medical imaging, virtual reality or VR, and augmented reality or AR.
Here are some of the specific reasons why OpenGL is important. The first one is performance. OpenGL is a hardware-accelerated API, which means that it can take advantage of the GPU to render graphics quality and efficiently. This is important for applications such as video games, which needs to able to render complex graphics in real time. The second one is flexibility. OpenGL is a low-level API, which means that it gives programmers a great deal of control over how graphics are rendered. This is important for developers who need to create custom graphics effects or who need to optimize their application for a specific hardware. The third one is portability. OpenGL is a cross-platform API, which means that it can be used to create applications that can run on a variety of different operating systems, including Windows, Mac OS, Linux, and Android. This is important for developers who want to create applications that can be used by a wide range of users. In addition to these specific benefits, OpenGL is also important because it is widely used API. This means that there is a large community of developers who are familiar with OpenGL and who can provide support and assistance. It also means that there are many resources available to help developers learn how to use OpenGL. Overall, OpenGL is an important graphics API because it is powerful, flexible, portable, and widely used. It's a good choice for developers who want to create graphics-intensive applications that can be used on a variety of different platforms.
Here are some specific examples of things you can do with OpenGL. The first one is create realistic 3D graphics for video games such as characters, environments, and objects. The next one is design and render 2D and 3D models for CAD and engineering applications. one is create interactive scientific visualizations such as simulations and data plots.
Hello everyone and welcome to this new lecture. In this lecture, we are going to cover data visualization. So let's get started. So in general, we are going to find there are four kind of very high level categories when we start to do visualizations. First, we have relationships. Second, we have comparisons. Third, we have distributions. And fourth, we have compositions. Again, pretty easy, pretty simple, straightforward stuff. I just wanted to cover it here just in case you might see on the AWS Machine Learning Certification exam. So first, regarding relationships, kind of two important relationships in here. The first one is what we call it scatter plot. And scatter plot demonstrates the relationship between two variables, x and y. Basically, I have here x, here I have y. I can plot all the values here in a scatter plot format. I want to plot, for example, let's say temperature, and I can plot, let's say here on the y-axis, the ice cream sales, for example. Have a bunch of points, plot them here, call it a day, and that will show me the relationship between the independent variable x and the dependent variable y. That's all what it is. Another way of demonstrating relationships is what we call a bubble chart. Bubble chart demonstrates the relationship between three variables, x, y, and bubble size as well. So I can plot here the x on the x-axis, let's say certain variable x. Here I can plot y. And in addition to that, now I have the size of the bubble. Okay, so now I can plot actually three variables together in one plot like that, using what we call the bubble chart. Okay, so again, that's another way of visualizing the relationships between variables. So now I have scatter plot and I have bubble plot, and these are kind of two belong to relationships. All right, the next one is comparison. So in comparisons, we have bar chart and we have line chart. So for bar chart, we can basically compare, let's say, employee salaries, for example. I can have employee 1, employee 2, 3, 4, and 5, and can by plotting that, then I would be able to compare the salaries of these different employees on a bar chart like that. However, here on the right-hand side, I can plot line chart. So I can compare median and average house prices over, let's say, the years, for example. So as you guys can see here, this is the median value. Let me zoom in. These are sales price in US dollars. Here we have the years. And by using the line chart, I can simply show the different basically the variations of the house prices as over the years, and I can as well, by plotting two of them, I can compare the two as well on the same chart. So for example, as you guys can see, these are the house sales prices in US dollars in the US. So basically, like beforehand back then, you can buy a house for, let's say, like 50K, for example, in 1975, in, let's say, the prime areas in US and even in Canada. However, right now in 2009, you need like $300,000. So like basically the value of the dollar diminishes extensively. So I can read all that information from the line chart, and I can also compare, let's say, the median and the average between the two right away in one stop shop. And that's why line chart, let me go back, line chart and bar chart can be used for comparisons. All right, what about distributions? So I can also visualize the distributions. One example is histograms. So as you guys can see here, this is a histogram, so I can plot the histogram, and I will be able to simply show the distribution of the data. I can know the mean, and I can know the standard deviation as well, which indicates the dispersion from the mean. I can also use a box plot to basically show me the median value, to show me what is my, what we call it, lower whisker and upper whisker. Think of it as the minimum and maximum values, and I can see the outliers as well. And because I know box plots might be a little bit confusing, that's why I decided to add a specific slide for box plots. It's actually pretty straightforward. So for the box plots here, this basically line indicates the minimum value. This one indicates the maximum value. Here we have the median here. Here in this rectangle indicates the majority of the data. So 50% percentile will be here. And any data here indicates the outliers. These are the outliers that basically we are going to remove it from the data because these screw up basically the machine learning algorithms. And we're going to see how we're going to use a strategy or a technique called random cut forest to actually remove the outliers for us as well. All right, what about compositions? So we can also visualize data using compositions such as pie chart, stacked bar chart, and stacked area chart. For example, here I can show on one pie, I can show the compositions, for example. I can see, let's say, like 31%, let's say, of the, for example, of of the Canadian population, for example, voted, let's say, Liberals, 44 voted, let's say, Conservatives, 19 with like NDP, something like that. So I can divide the Canadian, for example, population or the American population by using a pie chart, so I can see the composition as well. I can also use stacked bar chart like that. So basically I have, over the years, I can stack here on top of each other, let's say broad, mixed, standard, so I can see different compositions within 1 year, for example, okay? I can also here see stacked area chart, so I can stack basically the different variables in here in an area fashion, basically. That's, as you guys can see here, different. I have a blue area or a blue zone, green zone, and yellow zone as well. All right, okay, that's all what I have for this lecture. I hope you guys enjoyed it. Again, please bear in mind that again I have relationships, such as scatter plot, bubble chart. I have comparisons, such as bar chart and line chart. I have distributions, such as histograms and box plots. And these are box plots, basically explanation. And here I have compositions, including pie chart, stacked bar chart, and stacked area chart as well. All right, in the next lecture, we are going to cover distribution. So we're going to learn about normal distribution. We're going to learn about standard normal distribution, Poisson distribution, binomial distribution. We're going to be tons of fun. Please stay tuned and please enjoy AWS Machine Learning Certification course. And I will see you guys in the next lecture.
Next one is develop medical imaging applications such as MRI and CT scanners. The next one is create VR and AR applications that allow users to interact with virtual worlds and objects.
These days, we spend a lot of time looking at screens. Computers, smartphones, and televisions are a big part of our lives. They're how we get most of our news, use social media, watch movies, and more. Virtual reality and augmented reality are two technologies changing the way we use screens, creating new and exciting interactive experiences. Virtual reality, also known as VR, uses a headset with a built-in screen that displays a virtual environment for you to explore. These headsets use a technology called head tracking, which allows you to look around the environment by simply moving your head. Augmented reality, or AR, is a bit different. Instead of transporting you to a virtual world, it takes digital images and layers them on the real world around you. This is done through the use of either a clear visor or a smartphone. So with VR, you could explore a world full of dinosaurs. But with AR, you could see those dinosaurs moving through the world around you. Both of these technologies are growing at a rapid pace and being implemented in a variety of different ways. Surgeons are using VR to practice highly technical surgeries before operating. Businesses are using them to give consumers virtual tours of products and locations. There are even apps that can use your smartphone's camera to scan and translate a foreign language in real time. As they continue to grow, VR and AR have the potential to greatly change almost every industry. You'll want to keep an eye on them to see how they might soon affect your job and potentially your everyday life.
Goodwill Community Foundation, creating opportunities for a better life.
And the second one is animate 3D characters and objects for movies and TV shows.
What do you think of this? Is it grown up enough for my coming-of-age party?
Yes, you look like a princess.
Nah, my dress has to be perfect. People are coming from all over the kingdom.
The next one is edit and process videos, including adding special effects.
Welcome to my CapCut editing tutorial. Get your audio and clips. Step 1. Make sure your clips are on beat with your music, like this. Add a watermark. If you don't have one, then put some text with your name. Add your title. Here is what you recommend for text of any font. Add effects. One good effect is Retro DV2. Add your next clip. Make sure it is on beat. Repeat for all clips. Thanks for watching.
The next one is create and design graphic designs such as logos, icons, and typography.
Here are some examples of applications that use OpenGL. Video games, Minecraft, Grand Theft Auto, Dota 2, League of Legends, Fortnite, Call of Duty, FIFA, NBA 2K, Forza Horizon, and many more. Computer, Added Design, CAD, Auto CAD, SolidWorks, Inventor, CATI, and many more. scientific visualization, BTK, ParaView, visit, and many more. Medical imaging, OSNICS, ITK Snap, ImageJ, and many more. Virtual reality or VR, Oculus Rift, HTC Vive, PlayStation VR, and many more. Augmented reality or AR, Pokemon Go, Snapchat lenses, Google Map, Live View, and many more. 3D animation, Blender, 3D Max, Maya, Cinema 4, and many more. Video editing, Adobe After Effects, Premiere Pro, Sony Vegas Pro, and many more.
Open Graphics Pipeline. The OpenGL graphics pipeline is a sequence of steps that OpenGL takes to render objects. It can be divided into the following stages. The first stage, it is also called vertex processing. This stage transforms the vertices of each object from model space to clip space. Model space is the coordinate system of the object itself, while clip space is the coordinate system of the camera. The second stage is also called clipping. This stage discards any vertices that are outside of the view through screen, which is the visible portion of the scene. Stage 3, which is called rasterization. This stage converts the clip vertices into fragments, which are small pieces of the screen. The fourth stages. The first stage is fragment processing. This stage determines the final color of each fragment. This is where lighting, textures, and other effects are applied. The fifth stage is also called output merging. This stage combines the fragments from all of the objects to produce the final image. Each stage of the graphics pipeline can be used to customize by writing shaders. The shaders are programs that are executed on the GPU. They allow developers to have a great deal of control over how graphics are rendered.
Here is a brief overview of each stage of the OpenGL graphics pipeline. Number one is vortex processing. The vortex processing stage transforms the vertices of each object from model space to split space. Model space is the coordinate system of the object itself, while clip space is the coordinate system of the camera. Vertex processing can be used to apply transformation to objects such as transition, rotation, and scaling. Project object from 3D to 2D space. Calculate lighting and shading for each vertex. Number 2 is clipping. The clipping stage discards any vertices that are outside of the view cross tube, which is the visible portion of the scene. This is done to improve performance and to avoid rendering objects that are not visible to the user. Rasterization. The rasterization stage converts the clip vertices into fragments, which are small pieces of the screen. This is done by dividing each triangle into smaller triangles, and then dividing each triangle into fragments. The rasterization stage can be used to determine the screen coordinates of each fragment, calculate the perspective of each fragment, and calculate the depth of each fragment. The number 3 is 4.
Okay, up down up.
The number 4 is fragment processing. The fragment processing stage determines the final color of each fragment. This is where lighting, texture, and other effects are applied. Fragment processing can be used to calculate the lighting of each fragment, apply texture to each fragment, apply other effects, such as fog and transparency. The last one is output merging. The output merging stage combines the fragments from all the objects to produce the final image. This is done by blending the fragments together and then writing them to the screen. The output merging stage can be used to blend fragments together to create smooth transition between objects. Discard fragments that are behind other fragments. And the last one is write the fragment on the screen.